Hello and welcome back to Differential Equations, students. We got Unit 5 here, and we are on to video number 2. This is still 6.2 though. All right, and this is the only guaranteed example I'm going to do in this section. If time permits, I will make another one, okay? But this one is going to be decently lengthy, so hopefully you're going to watch this one a couple times and bring in questions if you have any. I want to find the two power series solutions about x equals 0. So it does tell me here that I'm going to do it about x equals 0, which really means that a equals 0. Okay. And this is my differential equation. So before I really even begin, I need to tackle whatever's out here. And since a sub 2 of x in this case here is just 1, there are no roots. Thus, all points are ordinary, right? That's what we tackled in the last video. So here's a key, right? Before, if their points are ordinary, what we had before was this definition that it should take on the form of a power series. N equals 0 to infinity of c sub n x minus a to the n, right? And what I said before was typically we have a is equal to 0, which we do have in this case, right? And if we have that, then basically I'm plugging a 0 here. So really I think that the solution will go from n equals 0 to infinity of c sub n x now to the n. Okay, that's what I think I have right now. So if that's the case, right, if I think this is the answer, right, the assumption is that's the answer. If that's the answer, then that is like a y, basically, right? That's y equals that thing. Okay, so if this is y, then when I go in here, I have to have y prime, and y prime here, and y double prime. So then I might as well go through and I might as well find those. So y prime of this thing now, right? Well, I'm taking it against x. So how would you do this? Well, if this were a 3, right, we'd put the 3 out here, then we'd take 3 minus 1 to make a 2. Well, now it's just an n. So as I'm doing this, this is the summation as n equals something to infinity. We're going to leave this blank for a second here. Now I drop down the n, then that's c sub n x to the n minus 1, right? Drop down the power, subtract 1. That seems right. Okay. Now, up above, I can't have a negative exponent sitting here because before I just wanted this n up here to just be to 0, right? I'm starting at 0 there. So here, how could I get the 0 up here? Well, I would have to have my n at 1, right? So this has changed, right? Now y prime has an index of 1 to infinity. Let's do the double prime version. That's n equals, okay, we'll leave it blank for a second here. I drop this one down, so it's n times n minus 1 now. C sub n, x to the n minus another 1 would make a minus 2. Again, same type of thing here. This can't be a negative, so that's going to have to start this at 2. Okay, that's a huge part. I believe that I need all these, right? I'm saying that this big equal sign here to this y, and then I have y prime, and then y double prime. And what I'm going to do is I'm going to take these and I'm going to plug them in right here. Okay, so I'm going to attempt to plug them in. Let's see if I can find some space. Let's do it in a different color. So I have, well, it's just y double prime at the start, so that's n equals 2 to infinity of n minus 1, c sub n x to the n minus 2. Then I had a plus 9x, and then we had y prime, well, y prime, n equals 1 to infinity n c sub n x to the n minus 1. Okay? And then it was a plus 3 with x, I believe. No, a y. So then a y, which means I need the original, right? And the original one was the summation is from 0 to infinity of c sub n x to the n. And then this equaled 0. Okay? So now I have this setup, right? And what happens here is I want to combine all of these summations. And this is why we did section 6.1 first. Okay, we're going to need to do some work to get all the indices to match and then to push them together. So before you go after like these, it's a very common mistake. Before you go after those, we have to tackle my x's. Okay, right now they're not all to the same power. So what I do is I implement this new like k, right? I need x to the k. So on this first one, right, what did I do last time? Well, in video 6.1, I did k equals n minus 2, which means that n equals k plus 2, right? And now I just start like plugging things in. I start plugging them in. So if I plug it in, I would have the summation. Okay, it's an n is k plus 2, so it's k plus 2 times k plus 2 minus 1, c sub k plus 2, x to the k, right? And then if I do a little bit of work just right here, right, it's k plus 2, which means the new index for k will be k equals 0 to infinity. Okay, that's this first section. If I try to keep this slightly color-coded. The next one here is I'm still just trying to tackle this. So I would need k equals n minus 1, which would then make it n equals k plus 1, which then means that I have plus 9x, the summation. Oh, okay, if it's k plus 1, it's k plus 1 here. Subtracting, I would have k equals 0 to infinity. Then I have my k plus 1 times c sub k plus 1, x to the k. Hopefully you're doing okay. If not, I'm hoping that you're stopping the video. This one here, pretty straightforward, right? I can just like straight just say n equals k, which then creates plus 3 summation as k equals 0 to infinity of c sub k, x to the k, and then this whole thing equals 0. All right. Now what I've shown so far looks right, and I think everybody in watching this video would probably do it just like that. The problem that I had actually is I made a small mistake, but it's gonna end up costing me big time. And maybe some of you saw this, but when I see this x here, it should have been like distributed in here because I'm manipulating the x's. When I take x to the first times x to the n minus 1, I get x to just the n. Why that's so much different is this stuff that I did here in purple, right? This stuff that I did in purple is now changed. It's fundamentally changed, okay? And I'm going to actually have to redo my, oh, now k, right? This is n just straight equals k. Oh, okay, so this would be a 9, the summation of k equals 1, because this was an n, right? And then I have to infinity of k c sub k x to the k, because again, it's taken on this value. And it's a very common mistake to do that, okay? Very, very common. But anytime you have this x and things, x out here, and you're manipulating an x, right, an x base, you're going to need to go in there and do that. Now that I'm here, okay, now that I'm here, I would love to just make this one giant summation. Some issues that I'm going to run into, of course, is that my indices don't match, right? How do we do that in 6.1? Well, I can't make this one go down to meet these others, but I can just evaluate it at k equals 0 for both of these, right? So if I do it at k equals 0, that's a 2. That would be a, 2 minus 1, that's 1, so that's a 2. And that would be a c sub 2. X to the 0 is just nothing, right? So there's my first one over here. Don't need that for the middle. But here, as I go after this one, this would be a 3 c sub 0 and then x to the 0. Okay. Now they should all be aligned, right? They should all be aligned. So I think I can get away with just kind of doing this math here. This is 3 sub c sub 0 plus 2 c sub 2 plus, now I have a single summation from k equals 1 to infinity. And now I just go in here and I try to tackle all these together. This one here, I'll do a little bit of simplifying. That's k plus 2, k plus 1, c sub k plus 2. Then I have plus, remember that these all have these x to the k's, so we're going to factor that out. All right. They also have these next two are going to have a c sub k. So when I do this, I'm probably going to add, well, it's 9 times k, so that's 9k. And then I have, well, 3 times c sub k, but that's really going to be factored out, so I just need the 3. These both had c sub k's. And then all of this had my x to the k, and this equals 0. Okay, and this is where we got last time, right? We got here last time in 6.1, and we ended up just stopping, right? Just stopping. Because this video is already 13 minutes long, what I think I'm going to do is I'm going to stop here. This is not solved. I just want to reiterate that this is not solved. Okay, we are going to finish solving it in the next video, so please make sure you watch that one. Okay, and the way I'm going to do it, if I just give you like a little taste of what's coming up, is when I look at this, I see that these are constants, right? These are constants. And this thing, technically, this thing, like, right, all this jazz right here is x to the k power. Okay, so it's x to some power. Now, over here, I have a 0 for a constant plus 0 x to the k. Okay, so you can kind of see what's going to happen. We're going to play the matchup game, which is what we've done before. Okay, but that's coming in the next video.